All right, so we have 2 sections left. The section we're doing today, tomorrow we're going to do more extra problems on this section, and then 8-7 is Monday, and we'll be doing more problems on Monday's topic on Tuesday. And then, I don't know, I guess maybe I'll leave it up to you if you'd like a quiz grade to offset some of your other quiz grades in there, and we can do a quiz over 8, 5, 6, and 7, or we can just go straight to a chapter test. What do you want to do?
So if we get a good quiz grade, then that would help us if we did that on the test.
That drop our lowest one, or is that what you're saying?
No, I'm just saying if you've got a low quiz grade and a decent test grade, if you have an extra quiz and you do okay on it, that can pull your quiz grade up. But
Sure.
we can just do a chapter test and skip the last quiz. Want to do a quiz? Okay. Okay. All right, so we'll probably do a quiz then on Wednesday next week. Work on the review Thursday, go through the review Friday, and then look at the chapter test on the following Monday for this chapter. Okay? All right, so this section is why we care about trig, because this is your application section, actually solving word problems, everybody's favorite. Okay? But this is why we care, because we can use trig, pilots use trig all the time in finding their bearings, trying to figure out how to get from here to there the fastest, what angle they need to be going with their trajectory, all of that. So it's used by NASA, it's used by aviation, it's used in your backyard if you're trying to figure out the height of a tree that you don't want to climb to measure. You can use trig to find it. Okay, so 2 important things you need to know when you deal with word problems in trig. First is something called the angle of elevation. So if I have this tree and the sun is up here, this is why I'm not an art major, and I am standing over here looking up at the sun, okay, my angle of elevation is always measured to a horizontal. So from my eye to the sun, this is called the angle of elevation. It's measured from the horizontal up to an object. I'm trying to see what that angle is to the object. Angle of elevation. Elevation, I always think up. Okay? If I'm out on top of a building and I see something over here and I'm looking down at it and I want to know what the angle of depression is measuring down, I always measure this to the horizontal as well. So it's not this angle. Not this angle. I do a horizontal line, it's this angle. Angle of depression. I can't even spell. Angle of depression. This one everybody seems to do okay with in this class when I've taught before. This one everyone wants to call it this angle. And it's always measured to a horizontal line, not a vertical line. Yeah, because what I could do then here is make my right triangle. Okay. What's interesting is if I'm down here looking up at a person up there, this is the angle of elevation. Well, because it's measured to a horizontal, those are parallel. So the angle of depression, the person looking down at me, is equal to the angle of elevation someone looking up at me would be because of alternate interior angles. Everybody see that? Okay, so whatever my angle of depression up here is my friend's angle of elevation down here. Okay, so it's never this angle, it's always this angle. Okay, so I'm just going to do a couple of examples of how you use this. And this says the angle of depression from the top of an apartment building to the base of a fountain in a nearby park is 72 degrees. So here's an apartment building. I have this fountain, and it tells me the angle of depression is 72 degrees, which is really not, because that's an acute angle, but I don't draw to scale in this class. You should know that by now. Okay. So it's really, the fountain's closer, so that angle's steeper, because it's 72 degrees. It's close to 90, but use your imagination. If the building is 78 feet tall, how far away is the fountain? Well, I could go ahead and draw my right triangle here, and I'm going to assume that this fountain is on the ground level with the building. So this height is 78 feet. I want to know how far away the building is from the fountain. That's that. Okay. What trig function can I use to solve for x? Tangent. I don't have the hypotenuse here. I have opposite and adjacent, which is TOA, tangent. So I could write tangent 72 degrees is equal to opposite over adjacent. And now to solve, I'm going to multiply both sides by x. So I have x tangent 72 equals 78. Divide both sides by tangent 72. Make sure my calculator is in degree mode, which it's not. And then just take 78 divided by tangent 72. So it is 25.3 feet away from the building. That's just using trig to real world problems. Okay, let's do another one. This will be a good one. A tree struck by lightning in a storm breaks and falls over to form a triangle with the ground. The only reason I thought this was a good one is I'm going to have to draw it. That's kind of fun. Okay, so I have this tree. Lightning strikes it. So now I have this tree that has fallen over. Poor guy. Something like that. And forms a triangle with the ground. See? This is why I'm not an art major. Yeah? It's beautiful. The tip of the tree makes a 36-degree angle with the ground, 25 feet from its base. So this angle is 36 degrees, and this distance is 25 feet. What was the height of the tree to the nearest foot? Well, what can I do here? The height of the tree originally was the base plus the top. So I need to find this piece and add them together. And that'll be the original height of the tree. Right? So let's find this piece. What would I use? Tangent again. Hypotenuse is opposite the 90. Does everybody see that? This is the hypotenuse. Right? Hypotenuse is used in sine and cosine. If I'm not looking for the hypotenuse and I don't have the hypotenuse, I will never use sine or cosine, because both of those use the hypotenuse. Okay, so if I'm looking for this, I'm going to use tangent because it's opposite over adjacent. Tangent 36 equals opposite over adjacent. Multiply both by 25. Tangent 36. 18.16 is this. And now I want to find the hypotenuse. I always use the whole number if I'm given it, because this is less precise. I just rounded it. This one is more precise, so I'm always going to use this. So I have adjacent hypotenuse. What do I use? Cosine. Cosine 36 equals adjacent over hypotenuse. Now I've got to multiply both by x and then divide both by cosine 36. So x equals 25 divided by cosine 36. 25 divided by cosine 36, 30.9. Just add those together. 49 feet is how tall that tree was originally. Before it broke. Okay? Okay, let's go through the textbook check. There's only like 5, 6 problems on big ideas. They're all, most all but one I think are word problems. Okay, and then tomorrow in class I'm going to give you a whole page full of word problems to work on, just for practice. Okay, so let's do the textbook check. The angle of elevation is measured to the horizontal. The angle of depression is measured to the vertical. False, they're both measured to the horizontal. Question 2. To find the height of the Washington Monument above, you would use which trig function? Well, if I want the height, that's opposite, and I have adjacent, so I would use tangent. To solve for angle x, you would need to use an inverse trig function. True, you always use inverse trig functions to find angles. You use regular trig functions to find sides. So if I'm looking for the angle, I'll have to use an inverse trig function. In the last video, bearings were discussed. Bearings are measured from what direction? Due north. Bearings are measured from north. And then 5 in the video, the bearing example used a car traveling along one bearing, then changing direction to travel along another. Obviously, everyone watched the videos. I can tell by how you're jumping for joy on these answers. Who got this one right? Huh? Who got this one correct? And what'd you say? True? What'd you say?
Sure. Yes.
It might really help you to watch the videos.
It is false.
Yes, it is false. Okay. That is it.